Hi everyone, welcome to C++ learning platform where we aim at teaching you how to program in C++ using a step-by-step do-it-yourself approach. I'm IPT, your instructor on this platform. Today, what are the objectives? Today, the short video here seeks to introduce you to loops statements in C++, such as the while, the do while, the jump, the for, the continue, and the break loops in C++. And we seek also to do some practical implementation. So, what is a loop? There may be a time when you writing a code and then you want to do a particular portion. You want a certain portion to go to run some number of times. So, for example, you want some lines to be repeated for a certain number of times. When that comes into your mind, then you have to realize that the way you can implement that is to use what loops. In general, when you look at the most programming language, is sequential, meaning that it starts from line 1, line 2, line 3, and keeps on going. So there's no way the application itself will stay on line 1 or line 2 and keep running on line 2 without going to line 3, unless you make it so with the help of loops. So there are a lot of structures, control structures that will help you to achieve this. And we've talked about this in our previous video. We've looked at decision statement. Today we'll be looking at some of these other loops that repetitive, iterative loops that we can use to repeat something a number of times. So what is a loop? Basically, as we have said, a loop statement what that allows us to execute a statement or a group of statement multiple times, so many times. So when we look at this figure, this is what is happening. So we come and check the condition. And if the condition is true, that is, if the condition is true, we go and execute a certain code. Then we come back again and check the condition again. If the condition is true, we go back to execute the same code. We come back until so it goes like it keeps on iterating until the condition is what false, where it leaves what the loop. To do this in C++, so many loops are available for handling repetitive or iterative process. We have what the while loop, while loop which repeats a statement or a group of statements while a given condition is true. So while the visitor is still in your house, keep on entertaining the visitor. So you have a visitor and you're entertaining the visitor. We are saying that as long as the visitor is there, while the visitor is there, you keep on entertaining the visitor. So if you look at it, you realize that for this one, it tests the condition before it executes while the visitor is there. So if there is no visitor, you will not be entertaining the visitor. Then we have what the for loop. For loop executes a sequence of statements multiple times and abbreviates the code that manages the loop variable. Then we have what the do while loop. The do while loop like the while loop, but this one it will perform the statement at least once before it goes and check the thing. Do while, do before you complain. So you do before you go and check and come back. We have got the nested word loops there where we can combine all these loops in one application or in one iteration to perform a certain task when the need arrives. So today we are concentrating on the for loop. So a for loop, is a repetition control structure. That's what allows you to efficiently write a loop that needs to execute a specific number of what time. I like this portion. So which means that this portion here is telling us that we use the value, we use the for loop, sorry, when we know when it, where to end. When we know where to end, a specific number of times. So I know the number of times I'm doing the thing. that is where I will use the for loop. So I want to give the guy mango 5 times. Then the for loop is applicable because I know when I'm stopping. So we use the for loop when we know where to stop. Okay, so let's look at the syntax. Now the syntax is very simple. The syntax is a keyword here which is for. Normal English word for. Then there's a open bracket here. Then there's what? Initialization, which is initialization. We have condition. We have what? Incremental. Normally, we have what? The closing bracket. Then open parenthesis here, curly bracket, and then the statement you want to execute, you have your close curly bracket. Now, normally all for loops have three variables inside. The initialization, where we start from, the condition, where we are stopping, the incrementer, the guy who is keeping track of how many times we have executed the loop, right? So, and then all these variables are normally integers. Okay, so let's see the flow diagram. So we have initialization, we initialize the loop, we check if the condition is true, and then we execute what? If the condition is true, we execute what? The block of code, right? And then we go to what? Increment. So if the condition is true, we come here. Now the condition is true, we come here. The condition is false, we come here, we stop. So if there's false, we stop. But if it is true, we execute the block of code here, then we increase the incrementer and come and check if the condition is still true. Then we keep on moving in this path as long as the condition is what? True. Immediately the condition executes false, we leave the loop. So the first item, as I said, is for the initialization. It's where the loop starts from, and the initialization value is executed once. This will allow you to declare and initialize any loop control value. Then from there we go to the condition. So we initialize the thing from a certain point. Check whether the initializing value compared to the condition is true, and then we move on to execute the body of the code. Come and increment it, and then check the condition. Execute the body of the code. Come and increment it. Check the condition. So this is what is happening. So we check the condition. Next, the condition is evaluated. If the condition is true, we go to the body of the loop and execute it. And if it is false, the body of the loop does not execute. The flow of control jumps to the next statement just after the for loop. So then if we execute the body, then we go to the incrementer. So anytime the body is executed, the next line is the incrementer to increase this counter, and then go and check if the condition. When this increment is done, the next thing we go and check the condition, and when the condition is true, we come and what? Execute the body of what? The loop. I hope you are following. Okay. So let's see examples here. So we are writing a C++ program that uses a for loop to add 5 numbers. The program should prompt the user to enter these values, that is these 5 numbers. So let's see what is happening. So we have the input here, which will be the 5 numbers. We process the numbers by summing all 5 numbers together, and then we print our output. So let's see what is happening. So I've done my declaration initializing of my for loop here. Let's see. So I have the keyword here for, as we learned from the syntax. I have my open bracket, int I. I'm initializing the loop because this loop is supposed to print take 5 numbers 1 to 5. So it's supposed to repeat itself 5 times. So I'm initializing it from what? 1 here, and then I say I. So don't forget semicolon as it is in the syntax. Then I is less or equal to 5, semicolon, I plus increase the counter by 1. So I will start from 1. is 1 less or equal to 5? It is true. What do we say? When the condition is true, we say that it will come and what? Execute the body. So to come and execute the body, what is the body of what? The body is this side. So here it says C out, enter a number, enter number I, and I is what? 1. So enter number 1. And then and we picked what the C in. Here we say sum is equal to sum plus what? Number. So let's say if we have a container full of mango and I give you another mango, or let's say 2 mangoes to add to the mango in the container. The new mango in your container will be the mangoes that were already in the container plus the new one I'm giving you, and they are all in the same container, right? So that is why we have sum is equal to sum plus what? Number. So add the new number to what is in the container sum and put all in the same container called sum. So when I is equal to 1, we print on the screen, pick the number, we do this. Then we increment. We said that when the body is executed, the next thing is to go to what? The incrementer. So when the body is executed, go to the incrementer. Incrementer says that I is equal to what? I plus 1. That's I plus 1. So I, which was 1 here, we add 1 to it, then we get to 2. So now the new value of I will be equal to 2. Is 2 less or equal to 5? If it is true, the body will be executed. We go and increment it. So we keep on executing the body, increasing the incrementer, checking the condition to see that still we are within the condition. So as long as the value of I becomes more than 5, then it has to leave this way. You come down here and print the sum of numbers I. The sum of numbers is what? The sum. Print whatever is stored in sum. I hope you are getting it. So remember that in our previous video we said that we can write, if let's say writing sum is equal to sum plus numbers, can also be written as this. So in place of this one here, this code, we can decide to put this one also here. And don't forget, if you are putting it, you have to bring your semicolon or remove, put it here so that the semicolon will still be there. So I run this one on my system, and then this is what I have. Enter number 1, I did this, I did that, I did that, and then the sum was equal to this. So you can also type this code in your compiler and run it and input several numbers to see what will be the output. So let's look at another example. Another example here is using a for loop. Write a C++ program that outputs all even numbers from 0 to 1. What is the task? The task is that we have 0 to 1,000, and 0 to 1,000, we are printing all even numbers that are here. Already in our previous video, we said even numbers are numbers that are divisible by 2, right? So now we use the for loop, we initialize the initializer. Int I is equal to 1. We are starting from 1, right? They will say I less or equal to 1,000, because we want from 0 to 1,000. So I should move from 1 to 1,000. Then I plus the incrementer. So now we come, I is equal to 1. So we say if I modulo 2 equals what? 0. We are checking if the value of I is what? An even number. And if it's an even number, we print it out here. So this is the body of this for loop here. The body is this one. So now when we check the initial value, which is what? 1, we do it and check, and if it is modulo 2 is equal to 0, we print it out. Then we come back here and increase the I by 1. So I will now get a value of 2. Then come and check if 2 is less than 1,000. And if it is true, we come and repeat what is in this loop. We go back here, increase the value of I by 1. Come and check if it is more than, is less or equal to 1,000. Come and repeat it, increase it, check, repeat, increase, check. So these 3 things keeps on what happening until this condition is met. If this condition becomes a false, I is not less or equal to 1,000, then you have to leave what you do. So you can copy this one, run it also, and see your output. Now let's see our last example for the day, using a for loop. Write C++ program that determines whether a given number is a prime number or not. And the question, what is a prime number? We all know that the prime number is a number that is divisible by 2, a number that has only 2 factors. 1 in the number itself. So every number that has more than 2 factors is not a prime number. So I'm using this idea or this knowledge on prime numbers to find a prime number. So let me just take it. Let's assume that somebody gives you a number like say 10. How do I know 10 is a prime number? You see that prime numbers are numbers that have what? Factors. Are you getting it? Two, only 2 factors. So now let's see, number 1 to number 1 to what? 10. The factors of 10 will lie from 1 to 10, right? The factors of 10 will lie from 1 to 10. So if you give me 10, it means that I have 1, 2, 3, 4 up to 10. And all these 1, 2, 3 up to 10 can be factors of 10. How will I know if these numbers are factors of 10? The only way to know is to pick 10 and divide it by each of these numbers. So if I'm able to pick 10 and divide by each of these numbers, I will know if the number divides 10 without a remainder exactly, then it means that that number is a factor of 10. So this is the idea we are going to use to implement it in C++. So now let's see what is happening here. We have our header files here. So I declare the number that the user will enter as number, and I declare this as what number of factors of this number. So I see out and the user will enter a number. I use this to pick the number. Then I come and say for int I equals 0, I less or equal to the number I plus 5. So listing from 1 to the number the person gave me, counting all the numbers that can fall within the number 1 to what the number the person gave me, and picking each of those numbers that can fall within 1 and the number the person gave, dividing the number he gave me by those what values, and checking the remainder is what 0. So I will start from 1. So if the person gave us 5, suppose he gave us 5, we are going to start I from 1. So I, which is 1, is less than 5, right? So now 5 divided by 1, what will be the remainder? The remainder of what? 0. So now I'll increase the counter by 1. So I've got 1 factor. Now I increases to what? To 2. So now we have number divided by 2, which is what? 2 remainder 1. So it's not a factor. I'll jump. Then we come. I increases to 3. So we have 5 divided by 3, which is remainder 1, remainder 2, sorry, which is not a factor. So I keep on. Then 4. So 5 divided by 4, which is 1, remainder what? 1. So it's not a factor. Then we have 5. 5 divided by 5 is what? 0. Is 1, remainder what? 0. So it's a factor. So we have gotten to 5, we have got to only 2 factors. So this is how we are looking through and counting the factors. So we come and say if the factors is less or equal to 2, then the number is a prime number. So if the total factors we had from here is less or equal to 2, then the number is a prime number. Else, that number is not a prime number. But hey, watch out. Suppose that the person gives us like 1,000. So do we have to iterate from 1 to 1,000? No, we don't have to do that. What can we do? We can always check to see within the for loop here if the counter is more than 2, because it should have only 2. So within the first, second, third, fourth, fifth, sixth iteration, we check and if the counter at every iteration, let's check if the number of factors has exceeded 2. Let's exit the loop. So we modify this loop using what? The break function here in the for loop. So what are we doing? So within the for loop, at every point we check if counter is greater than 2, break, exit the loop. The number is not a prime number. So I urge you to type this one into your compilers and run them also and see the output. Hey guys, don't forget, any comments on what you are doing, if you are facing any problem, email us or send us a comment on our YouTube channel, and we'll be glad to give you a helping hand. Thank you for watching this video. We appreciate you watching our video, and we pray that this video that you are watching, it will be a blessing to you, and you can it will help you to improve your knowledge in programming and also be a help to others. Stay blessed, stay safe. Let's meet again on this same channel for our next tutorial. Thank you.